In this example, we're going to look at a fantastic new capability in motion simulation called event-based simulation. It uses a sequencing operation to determine the movement of parts and the machinery. One new capability that we've added in here is what we call a proximity sensor. The sensor is used to define when things are going to come into, detect when things are going to come into contact. For example, think of it as a laser beam where we've attached it at the midpoint of this edge in this direction, and it's going to trigger an alert if that distance to this part in purple is ever less than 49 millimeters. So it's looking in the line of sight, and if that part is ever there, it will trigger that event. So you can do lots of different things with that proximity sensor. The event-based simulation also supports other sensors such as displacement sensors and so on. So let's take a look at how we get that set up. What we've got here is a series of motors driving these little pushers, and we're going to basically move this block around the system. And we've got a contact definer between that block and all the other components. Now, something new in 2010 is we have what we call a servo motor, which is basically, when we set it to displacement, a position motor. What we do is it doesn't have a current value, we just change the value at different time events to adjust the current position of the servo. To get to the event-based motion, we just click on this button over here to go to the event-based view. Now in the current beta build there's an issue where it's not turning on these motors by default, so I've just set up some initial tasks to do that. But what we do is simply go through and start creating our operations. For example, at time 0, we'll just set this, we'll create a new task. We're going to call this extend actuator 1. Okay, so then for our action, we pick from a series of options. We've got end motion, we can turn mates on and off if we wanted to. In this case we're just going to pick the linear motor, which is number 5. You see it highlights it there on the screen. We're just going to change that, so instead of being at the current position, we'll increase its position by 200 millimeters. We'll do that over 1 second. We've got lots of profiles for how it's going to interpolate. We're going to use cycloidal, so it ends with 0 acceleration. Go to our next task, and we're going to, once that task is finished, we've got to extend the second actuator. So we go extend actuator 2. And instead of this occurring at a certain time, this is where we get the real power, by extending it after a task is completed. So we're going to extend it after we've done the actuator 1. And again, we set our action, we pick the second motor, which is going to be this one. And then we just, again, change that one to 200 mil over 1 second. And we could add events in here to actually retract this after the other event. I'm not going to do that to speed it up. You can look at the completed study to see that. Okay, then we're going to do this final one, extend, second last one, sorry, actuator 3. And again, we're going to do this one after the second task is complete when we extend actuator 2. Pick our motor, and it's going to be 7, so you can get visual confirmation there. And again, we'll do cycloidal. Now again, the power of all this is because these are dependent. If we come back here and change that to 2 seconds, the others are going to update automatically. That's a great thing. To do it normally would have been quite a lot of work. Alright, let's extend the last actuator. This again will be after task 3. The order of these, you can order these tasks. For example, you see here you can lock tasks, delete, suppress, duplicate, etc. A lot of capability there. Last one, which is 8, and just double check. Yep. Again, we'll do that 200 millimeter over 1 second. Alright, so remember we've got contact defined, we've got gravity, so we should be good to go. What we'll do is just crank up. It's already got 50 frames, that's good. So click on calculate, you'll see it does the different operations, and it highlights those operations in the event tasks while it's doing them. And then I should push it out. There we go. That's just a quick example of doing that. For example, we can come in here and change the different cycle times, and just by simply redoing the run, it's going to automatically solve the new times, which is, you know, that's fantastic capability versus having to go in and adjust keyframes before. What we need to do, I think we ran out of time. Something else we can do in here is we can set a task so that after task 4 is complete, we can stop the simulation. So if we go back to our other view, yeah, that's the reason. So let's just change it, crank it out. So you can see while it's solving, it's actually building up the keyframes for us, which is a great capability. And again, you'll see that update accordingly. And there we go. So you see the completed solution, here's the full one. And you'll see that in this system I've actually got it to actually extend and retract the actuators at the different points. So you see it extends it out, and then the others return afterwards as well. A really fantastic capability.